In today's lesson, we are going to be identifying linear functions. So in the past, we took a look at whether a relationship was a function or not. Now we're going to take a look at specific functions and see if they are linear, because all of these tables are functions. They all have, each input has one unique output. All right, all the x values are different here, here, all the x values are different. So these are all considered functions now. Now we want to see if they're linear. So to see if these are linear, we have to see if they have a constant rate of change. They have a constant slope between each point, or a constant rise over run, or a constant change in y over the change in x's. So we have to pretty much calculate the slope or the rate of change between each set of points to see if it is linear. All right, so in the first one here, this one goes down 3 over 2, right? The next part, you go down 3 over 1. So automatically right here, negative 3 over 2, right? That's not going to be the same thing as negative 3 over 1, so it doesn't have a constant rate of change. So this is not linear. All right, let's take a look at the next one. Negative 1 to 2 goes up 3. Negative 6 to negative 1 goes to the right 5. All right, the next set, 2 to 4 goes up 2, and then this one goes up to the right 5. So 3 over 5 is not the same thing as 2 over 5. So again, this one is not linear. All right, let's take a look at C. Move this down a little bit. So with this one, 6 to 3 goes down 3 to the right 1. This one goes down 5 to the right 2. Is negative 3 over 1 the same thing as negative 5 over 2? No. Negative 3 over 1 is not equal to negative 5 over 2. So this is not linear. Let's take a look at the last one. All right, negative 6 to negative 5 goes up 1 to the right 2. So that one's up 1 to the right 2. The next one goes up 2 to the right 4. Is 1 over 2 the same thing as 2 over 4? I mean, if you're good with your fractions and knowing how to reduce it, you would know, but you can double check in your calculator. 1 divided by 2 is 0.5. 2 divided by 4 is also 0.5. So that is the same constant rate of change. Or if you just reduce this, it is 1/2. All right, let's keep going and see. So we know that's equal. All right, and let's look at the next interval. This one goes up 1 to the right 2. It's all the same. They have all the same constant rate of change. It's basically reduced. It's 1 over 2. So the slope of this, the constant rate of change, is 1 over 2, which is also equal to 0.5. All right. And so this one is linear. So that's how you tell whether or not a table is linear or not, by looking at the constant rate of change. All right, let's take a look at equations, whether they are linear or not. So linear equations, right over here. Linear equations are in slope-intercept formed, y equals mx plus b. All right. That means it would have a slope, an intercept. Sometimes the intercept might not be there because it could be 0. You could have an equation look like this, and it is a linear equation, y equals 3x, right? Because the b would be 0. You can have an equation that looks like this, 1/2 x plus 5, right? You could have a linear equation that looks like this. Let me write it below here. Y equals -4 minus x, right? Still in slope-intercept form, we just switched around the numbers. You still have an x, you have a b, right? You have an m, which is -1. All right, these are all linear equations. Maybe one more example. You could have a fraction as a constant in the equation. For example, 3x plus 1/2, right? Because 1/2 is 0.5. So that's another example of a linear equation. All right, now let's look at a couple examples of what not a linear equation is. So not a linear equation. Definitely when you see an exponent. So if you see something like this, 3x squared plus 2. So when you see the exponent with the x value, that is not considered a linear equation. Whenever you see an x on the bottom of a fraction, so 4 over x plus 3, all right, that would be an example of not a linear equation because the x either has to be on the top or it has to be on the side here. What else is not linear? I think that's pretty much it. You're not going to see any other thing besides that. All right, because you could have fractions. You could have fractions. You could have this. This would be considered linear. So going back to linear part, you could have something like this with an exponent. Y equals 2x minus 3 squared, because what is 2x minus 3 squared? It's 2x minus 9, right? So you can simplify it. So always try to simplify it first before you see whether it is in slope-intercept form. Okay. All right, so that is it for today's video on determining whether an equation is linear or not. So remember, with a table, it has to have a constant rate of change, a constant slope between each point, and you might have to reduce those fractions to see that. And with an equation, it has to be in slope-intercept form. Those are the two key things. All right, so that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.